First of all, thanks to Rise of AI for the opportunity to present. I'm DINAKAR MUNAGALA, co-founder and CEO of THINCI. We're an AI computing solutions company. So what we have at the core of our innovation is a novel processor architecture, which is suitable for AI, class of workloads, CNN, computer vision, any general complex graph we process really well. And it's completely programmable, and then software on top of it to enable different applications. Today we're here to talk about, as a young company, how we see AI coming to the masses, right? And what are some of the barriers for adoption, and some of the things that are happening to overcome those barriers, and widespread adoption, and then the benefits. That's the theme. But on a lighter note, to start off, this is actually something quite common that we see in companies, that almost any company we visit, or even otherwise, the companies want to be AI first, but there are barriers, right? There are cost barriers, talent barriers, preventing that, the time for adoption, the tools, etc., and then data. So this is a common theme that we see. So AI, what's the big deal about AI, right? As several of the people in today's conference mentioned, this is a key inflection point, and it's proliferating to different aspects of our lives, everyday lives. And historically, if you look at it the last couple of 100 years, there have been such key inflection points. It was the Industrial Revolution, followed by the Electrical Revolution, followed by the PC revolution, and then mobile and internet, and then now the AI revolution. So at each such key inflection points, what it coincided with is some new innovation, coming to the table. And as a result, new industries were formed, new jobs were created, new wealth was created, new companies were formed. Some of the older ways of doing things got more efficient and were done away with. So that was the general theme. AI will be no different from that. We expect similar trends to follow here as well, and a lot of benefits to come about. So let's just look at in the more modern computing history, right, what we know of the PC and then the mobile and internet era. What were some of the common themes? The PC revolution happened because there was a cheap, I shouldn't say cheap, affordable computing rather, an affordable but powerful computing machine that happened. The concept of an operating system and good tool chains around it, right, be it word processing, Excel, etc., to help create applications and productivity. And the third one was internet, right? Being able to share, be connected with the rest of the worldwide population and share your work. If you look at the mobile revolution, on the other hand, some of the cool things that happened that made it such a huge success was a really cool UI, right? It was so natural, touch, easy to use, and an app store model, which was anything you want, for any problem that's in your life, call a cab or whatnot. There's an app for everything. So the concept of having a personal device close to you and have all these solutions to help your everyday life. And then, of course, connectivity, right? So those were the common themes that helped the PC and the mobile revolution. We believe that similar trends are needed to happen, are required for AI to come to the masses as well, right? So the concept of affordable but powerful compute both for training as well as edge inference, being powerful yet power efficient. Ease of building applications, having adequate access to data, having models which are pre-built and easy to use, and then self-customized AI applications for a specific circumstance. So these are the kind of things that are needed really for the whole AI personal computing wave to happen. But there are barriers as we see it today. One of the first barrier is cost. Right? The cost of compute is pretty high. And most of you here are either parts of an AI developing team or part of a company that's exposed to large servers on which AI is developed. So the cost of actually building and maintaining an AI solution is pretty high. And that comes down to compute. The second one is talent. Right? There is a shortage of talent. Very few people actually understand how to build an AI application completely, compared to the worldwide developer population, that is. And data is the key ingredient to create any AI application, but data is scarce. Right? That's something that has to be solved. And the time it takes to build an AI application is fairly long. We're talking about months and so on. So drilling down a little bit deeper into these, the very first thing is compute. So today, if somebody wants to build an AI application, there are three choices, right? A few choices, I should say. Go to the cloud, and you're paying per hour. Quickly, the costs add up, right? If it takes about 6 months to build an application, renting cloud resources to train is pretty expensive. Few companies can afford it, but not for either independent developers or etc. Right? So for example, if you take the analogy of how the PC industry happened and lots of developers started coding, for that to happen, compute has to be a lot cheaper. The second option is buy an expensive a desktop box. It could be a DGX, it could be another brand, but the point is that the costs are anywhere between $180,000 to $250,000 to $300,000. So how many even small or mid-sized companies or even individual teams can actually afford it, right? It's pretty expensive. The third option is buy a cheaper GPU. It's cost efficient, but then as you train, it takes a lot of time. Right? A simple model will take about 3 days to train. And once you do all this, where do you deploy it, right? You need powerful hardware, powerful but power-efficient hardware at the edge to deploy a solution. That's the challenge as well. The second problem we spoke about was skills and talented people. Right? So it so happens that AI came out of nowhere suddenly in an exponential growth. Therefore, there is a shortage of skilled people who understand how to actually build AI applications. So currently, the tools are targeted towards few people who are experts at AI, right? All the tools. The tools are the ones which bridge the gap between having an AI expertise and building an application versus not having expertise but being able to build an application. So the tools are inherently not the way they should be to help AI development. The second one is, in general, even if you look at the worldwide AI population, Tencent did a study that there were only about 300,000 AI researchers and practitioners on the whole planet. But what is required is like millions of them. McKinsey predicts that by about 2024, US alone will be short by 250,000 data scientists. So these are pretty big numbers, right? So how do you actually solve this? The gap between what a developer can do versus what is expected from in order to build an AI application. So how can tools help bridge that gap is the key question. The third part is data. Right? Data is scarce. Data is hard to get. We've seen it as a young company as we built some demo applications in our company. 50 to 60% of our time was actually spent on getting data, good quality data, cleaning it up, labeling it, and then presenting it to train. And this is a common theme that we've seen to any company that we've spoken with. 50 to 60% is just spent on getting the data even before they start training. So this is a pretty big pain point that has to be addressed. So the combination of all of this translates to this. So at a high level, if there are three phases, right? Getting good quality data, and then training it, and training a model for a particular problem that you want to solve, and then deploying it to hardware in a very efficient manner. It takes a pretty large team, large and experienced, a lot of expertise. So you need data engineers, data scientists, ML engineers, C++ developers, UI, and IT to maintain the infrastructure. So it's a sizable operation to actually truly build an AI application. And the time it takes is about months or years. And the cost of compute is pretty significant. It's millions of dollars when you finally look at the cost of building an application, maintaining the infrastructure, retraining, et cetera, over a period of a life cycle of a project. So what are some of the optimistic things that are happening in the industry to solve all these problems and truly lower the bar to make AI happen, right, in a democratic fashion? The very first thing is looking at it, again, bottoms up from a compute point of view, the cost of compute and the efficiency of compute. CPUs have been around for some time, right, 40 years plus, and they exploited instruction-level parallelism really efficiently. Then came along DSPs, which did data parallel really well. And then GPUs started off with thread-level, multiple threads and thread-level parallelism. And here we are in the next era of computing, where you have a lot of tasks running in parallel, layers and layers of neural networks or CNNs with other kind of algorithms, all running in parallel. So hardware architectures which are able to exploit this parallelism and do it in a very cost-efficient manner is the answer that can actually help efficiency and reduce cost. So we call this essentially graph streaming processors. So this is a chart that shows different kinds of hardware architectures on the top, right, all the way from 1950s till now, and different kinds of software programming approaches that went hand in hand with these processor architectures over the years. So it's a busy chart, but the theme, the message is this. Every time there's a new processor architecture, it coincided within a short window, a new kind of programming approach. Here we are in 2019, and much of the problems in the AI world are graph kind of problems. There are many, many tasks, neural networks and whatnot, and yet the hardware that these are being ported onto, because of the fact that the hardware that exists, are CPUs and GPUs. So therein lies some inefficiency, right, and more expensive, more power consumption, and so on. So what's needed is a true architecture that can actually understand these graph languages in a nice programmable fashion and accelerate them well. It is a pretty widely accepted fact now in the technology community that besides the CPU and GPU, there is the need for an additional type of processor that is suitable for AI kind of workloads, which are going to dominate for the next 20, 30 years. So coming back to how do you address the gap of skills and how do tools kind of rise to occasion to solve these problems, right? What you have on the top is a typical way of building an AI applications. You need a combination of ML engineers, data engineers, and data scientists. What you have at the bottom is some of these forces that are happening in pockets to truly enable these kind of people to develop applications. So moving from Python and R-based approaches to either C++ or Java, which is more developers have been used to it more. That you have when you look at a worldwide developer population, much more of them actually are familiar with those. So that enables a regular developer to build an AI application. Similarly, database admins using SQL can get data, rich data, and make it presentable to train. And wouldn't it be cool if a business analyst was able to use transfer learning techniques to train versus just data scientists being the only ones being able to train? So as a result of all these forces, what ends up happening is, if there's a way that almost there's no coding experience required, right? Low code to zero code kind of experience required to create a nice AI application for a specific problem, using transfer learning, better tools, and so on. What it enables is the concept of a citizen data scientist, somebody who's not really a data scientist, but a person who can use intuitive tools to build an AI application. One of the next key challenge is data. We are seeing marketplaces happen. That's going to be big. Transfer learning is going to be big. We see that the concept of last layer training, right? Taking a model from somebody who's built, let's say, a model for face recognition on the other side of the planet, and I customize it for specifically my office, and just do some minimal training to recognize people coming into the office or onto a shop floor. So these kind of things are simple things, and but yet they're powerful, and they're easy to realize an application. And having marketplaces freely distribute such models is going to lower the barrier truly. And being able to create good quality synthetic data sets. Synthetic data is already happening. For example, in the world of autonomous driving, several of the car OEMs and companies, what they're doing is, instead of sticking cameras on cars and driving around the streets for, let's say, 6 years of testing time, that time is becoming shorter and shorter, because much of the autonomous driving work is actually happening in the lab in a synthetic world, be it freeway driving or urban settings. So the whole idea is, how do you do much of your testing, maybe 70-80% of your testing your algorithms in a synthetic environment, and then you still go for a real-world testing for the remaining 20%. Now, autonomous driving is still sort of a mission-critical set thing, and you need real-life testing quite a bit. But what if you could have synthetic data sets to do training into several other areas that you want to deploy, right? That's going to be interesting. And we are seeing efforts in that area. So therefore, with the combination of all of these things that are happening, what you see is, instead of needing a large and expensive team of people to build a complex AI applications, we're able to use really intelligent and intuitive tools to build an AI application. Developers who are not as AI aware can also build these AI applications. What took about months and years to build AI applications and train and deploy is coming down to a few days to a month. And the cost of compute and storage, what was millions of dollars, truly can come down. So the goal is really, if you're able to crack the PC price point, right? Because the world's used to a PC price point, a few $1,000s or maybe a few $100s, that kind of a price point, and really have good, powerful hardware to train as well as deploy. That's going to be an interesting point where mass adoption can happen. So once you have all this, the big benefits, right, is that instead of smart people trying to focus on, hey, what's my environment, which version of Linux, what is the tool chain, what is the environment going to look like, and trying to solve those problems, they can instead focus on really important problems, right? Solving climate change, better healthcare, and so on, right? They're thinking about what are the big problems and what are the outcomes that they need and trying to solve that problem. So these are some of the big things, benefits that can happen. Of course, the list is pretty endless. Applying it, for example, to agriculture and hunger, right? Better prediction of crop yields, understanding climate risks, bringing down insurance costs. There are some efforts that we saw where certain kinds of seeds are more suitable for areas which have, let's say, typhoons or any kind of natural weather risks. So using AI to understand what kind of crops can do better in those kind of climate and helping the farmers to grow that and thereby improving productivity and reducing the risk. Students having access to AI and building applications and understanding the whole AI sooner so that as they get out of school, they are able to work with all the AI, the changes that are happening due to AI. AI as teachers to remote areas, right? Having high quality education for kids in developed nations, for example. And also in other countries, every student is different. So wouldn't it be nice if AI is able to customize education to each kid's specific need? So for example, a kid is, let's say, good in math but weak in biology, or vice versa, having an appropriate curriculum, appropriate tests to help that kid to do better. Energy and utilities. For example, learning that how efficiently grid can be managed in a different geography and applying that to another country, right? Sort of cross geography and applying those learnings so that energy efficiency is really improved. Medicine is one of the big areas that we're seeing a lot of development, for example. It just took about, 2 years ago, it took about a month to screen 20 to 30 molecules against 150K protein targets. And we're right now able to, with deep learning, bring the time down to just 2 hours and screen about 10,000 molecules against the entire human proteome. And drug discovery can be accelerated significantly because of this. Disease eradication. I've come across at least about 3 or 4 startups in just about a span of 6 months who are either trying to predict cancer early or diagnose different disease and so on. I wish they all succeed and big benefits do happen for mankind. Having quality healthcare for uninsured and underinsured based on an AI-based physician, for example, right? And give it, have that happen for the whole population. Insurance costs come down. You have overall a better, more healthy population. So large-scale benefits can happen. These are a few of them, but really the possibilities are endless. We're happy to be part of this journey, and it's exciting. Thanks for the opportunity, and open to any questions.